All right, let's talk about what happens when you turn out the lights. We're going to pull back the curtain on sleep and show you the absolutely critical work your brain is doing on its night shift, work that has a huge impact on your memory and, believe it or not, your long-term risk for diseases like Alzheimer's.
You know the feeling, right? We've all been there. You toss and turn all night, and the next day, ugh, it feels like you're trying to walk through mud. You can't focus. You forget the simplest things. Your thinking is just slow. It's such a common experience, but what's really going on? It's a lot more than just being tired.
That brain fog? That's not just in your head. Well, it is, but it's a real physical signal. It's a warning light on your dashboard. It's your brain telling you that its crucial nightly work got interrupted. Major jobs were left half done, and now the whole operation is struggling to function. For so long, people thought of sleep as just downtime. The brain just switches off, recharges, and that's it. But we now know that is completely fundamentally wrong. Sleep is one of the most active periods for your brain. It's a highly organized, absolutely essential process where your brain is working overtime. So, what's first on the brain's nightly to-do list? It's acting like a master archivist. Think about it. All day long, you are bombarded with new information, creating new memories. At night, your brain has to sort all of that, process it, and file it away properly. Let's dig into how that actually happens. So every time you learn something new, someone's name, a new recipe, the key points from a work call, that information lands right here, in a part of the brain called the hippocampus. The best way to think about it is like your email inbox, or maybe a temporary downloads folder on your computer. It's great at quickly receiving and holding on to new stuff, but its capacity is really limited. It was never meant for permanent storage. Now, for a memory to really stick, to become permanent, it has to be moved out of that temporary inbox and into a much bigger, more stable place. That place is the cerebral cortex. This isn't an inbox. This is the brain's enormous, long-term library. The connections here are strong and stable, and this is where memories can live for a lifetime, all neatly integrated with everything else you know. And that's the million-dollar question, isn't it? How does that transfer happen? How do those temporary files get moved into the permanent archive? Well, it turns out this incredibly important process doesn't happen when you're awake and dealing with a million other things. It happens almost exclusively while you're asleep. This whole process is called memory consolidation, and it's a carefully choreographed dance that happens overnight. So, step 1. During the day, your hippocampus is busy encoding everything you experience. Then, and this is key, as you enter deep sleep, your brainwaves actually slow way down. This opens up a special communication channel between that temporary inbox, the hippocampus, and the long-term library, the cortex. The hippocampus then replays the important events of the day almost like a highlights reel and sends those memories over to be filed away. And finally, the cortex strengthens the connections for those new memories, locking them into permanent storage. So here's the bottom line. If you don't get enough of that deep sleep, that special communication channel between the inbox and the library never really opens up, or it slams shut way too early. The transfer is left incomplete, and those memories, they're basically lost. It's exactly like typing up a long document and then having the power go out before you hit save. It's just gone. And that leads directly to all those symptoms we know so well. You forget what your friend told you yesterday? Well, that's probably a memory that never got filed away properly. You're struggling to learn a new skill at work? It could be that your hippocampus is still clogged with yesterday's unprocessed junk, so it has no room to take in new information. See, this isn't some kind of personal failure, it's a biological machine getting jammed. Okay, so filing memories is job number 1. But there's another job that's just as important happening at the exact same time: sanitation. I mean, every factory produces waste, right? And the brain, being the hardest working organ in your body, produces a ton of it. So at night, the cleanup crew comes in. This right here is one of the most incredible discoveries in modern neuroscience: the glymphatic system. It is literally the brain's dedicated waste clearance system. And get this, it's up to 10 times more active while you sleep than when you're awake. But here's the truly mind-blowing part. During deep sleep, your brain cells actually shrink, which widens the channels between them so that a special fluid can rush in and literally power wash your brain clean. It's amazing. So what is all this trash that needs to be cleaned out? Well, the main culprits are these toxic proteins that are just the natural byproducts of your brain cells firing all day long. Two of the most infamous of these are called beta-amyloid and tau. Now, in small amounts, your brain can handle them, but if they're not cleared away every single night, they start to build up, stick together, and become really, really destructive. So let's walk through it. As you hit that deep sleep stage, the glymphatic system just kicks into high gear. This cerebral spinal fluid is pumped deep into your brain tissue, where it collects all that beta-amyloid, tau, and other metabolic gunk. This toxic soup then gets flushed out of the brain and into your body's regular circulatory system, where it can be safely disposed of. By the time you wake up, your brain is cleaned, it's refreshed, and it's ready for another day of hard work. It's a pretty simple question, but the answer is, well, it's terrifying. What happens when the sanitation crew keeps getting sent home early? The trash doesn't just vanish into thin air. It piles up, day after day, week after week, and year after year. And this is the direct result. That buildup of beta-amyloid and tau is toxic. It literally gums up the works, interfering with how your brain cells talk to each other. It triggers chronic inflammation, and eventually it just starts killing off brain cells. This isn't just a theory. This exact accumulation is the physical hallmark of Alzheimer's disease. And that leads us to this really dangerous feedback loop. You see, the link between bad sleep and Alzheimer's isn't a one-way street. No, it's a vicious cycle where each problem actively makes the other one worse. Okay, let's break this down. It all starts here. For whatever reason, you go through a period of poor sleep. Maybe it's stress, a new job, a sleep disorder you don't know about. Because you aren't getting that deep sleep, the glymphatic system, the cleanup crew, can't do its job. So beta-amyloid and tau start to build up. Now, this is where the cycle gets really nasty and turns back on itself. These toxic proteins, they don't just build up anywhere. They seem to be particularly damaging to specific parts of the brain, including the very areas that help you generate deep sleep in the first place. So the trash is now literally breaking the cleaning equipment. And that leads to the final, awful step in the loop. With your brain's own sleep centers now damaged, your ability to get the deep, restorative sleep you need is even more compromised, which of course leads to even more toxic protein buildup. And the cycle just repeats, spiraling downward, getting worse and worse, often for years or even decades, before the really obvious cognitive symptoms show up. And if you need a really stark reminder of just how immediate this is, look at this. Research has actually shown that just one single night of sleep deprivation can lead to a measurable increase of beta-amyloid in the brain. This isn't some process that only matters decades down the line. It's happening on a microscopic level every single night. So, given how high the stakes are, we really need to understand the specific conditions that can chronically mess with this nightly work. We're not just talking about a few bad nights of sleep here. These are medical disorders that systematically stop the brain from doing its essential jobs. First up, obstructive sleep apnea. This is a physical problem where your airway actually collapses while you're sleeping, causing you to stop breathing for seconds, sometimes even minutes at a time. Every time that happens, your oxygen levels plummet and your brain freaks out. It sends a panic signal to wake you up just enough to gasp for air. This can happen hundreds of times a night without you even knowing it, completely shattering your sleep architecture and preventing you from ever staying in that deep, restorative sleep you need. Then you have chronic insomnia. This is that persistent, frustrating struggle to fall asleep or stay asleep, even when you have the chance. We're not talking about a few bad nights. This is a long-term state of sleep deprivation. And night after night, the brain's essential work shifts get cut short. The glymphatic system doesn't finish its cleaning run, the hippocampus doesn't finish transferring memories, and over time, that nightly deficit just builds and builds into a huge problem. And finally, let's talk about circadian rhythm disruption. Your brain has a master internal clock that runs on a roughly 24-hour cycle. It expects you to be asleep when it's dark and awake when it's light. Things like shift work, constant jet lag, or even just a really chaotic sleep schedule completely throw this clock out of whack. It creates this state of permanent internal jet lag, messing up the precise timing of all those nightly brain processes, and studies show it can directly impair memory and even speed up how fast your brain ages. Now, it's so important to draw a clear line here. If you're having memory problems, please don't automatically jump to the worst-case scenario. Sleep-related memory loss is usually pretty variable. You'll have good days and bad days. The most crucial difference is that it gets better when you get better sleep. It mainly messes with your attention and your ability to recall recent things. Alzheimer's, on the other hand, is a relentless, progressive decline. It does not get better with a good night's rest, and it fundamentally damages your ability to learn new information and function in daily life. But here's the key takeaway. Untreated chronic sleep problems can be the bridge that takes you from the first column over to the second. Okay, after all of that, I know it can sound a little grim, but this next part, this is truly the most powerful and hopeful part of this whole story. Unlike so many other risk factors for dementia, sleep is something you have a huge amount of control over, and that is the key to the solution. So, can making a real effort to improve your sleep actually lower your risk for Alzheimer's? The evidence we have is overwhelming. Yes, absolutely. Because the quality of your sleep is so directly tied to the very physical mechanisms that cause the disease, that buildup of toxic proteins, improving your sleep is one of the single most impactful things you can do to protect your brain. Just think about it. When you make it a priority to get consistent, high-quality sleep, you are directly helping your brain. You are giving that glymphatic system the full shift it needs to clear out beta-amyloid and tau. You're giving your hippocampus the time it needs to successfully file away your memories. These actions might not just protect you in the future. There's even evidence they could help slow down existing cognitive issues. So when is it time to talk to a doctor about this? Well, look for some clear signs. We're talking about persistent memory problems, not just one-off day. If your partner says you snore really loudly or even stop breathing at night, that's a huge one. If you're feeling exhausted all day long, even though you were in bed for 8 hours, that's a massive red flag for what we call non-restorative sleep. And for sure, if you're noticing cognitive decline, a full sleep evaluation should be one of the very first things you do. This right here is the main message. You can't change your genes, you can't change your age, but you absolutely can change your sleep habits and get treatment for underlying sleep disorders. This puts a tremendous amount of power and control back in your hands. It reframes sleep from being a luxury to being a non-negotiable part of preventative medicine for your brain. We really have to get out of this mindset that sleep is the first thing we can sacrifice when life gets busy. It's not optional. The work that's happening during that night shift, filing your memories, cleaning out toxic waste, it's a biological necessity, plain and simple. In the end, it all boils down to this. Safeguarding your sleep is one of the most profound investments you can make in your long-term brain health. Protecting your sleep isn't just about feeling more awake tomorrow, it's about protecting your memories and protecting who you are for all the tomorrows to come.